All right, so for potentially the last video of this series, I want to basically demonstrate how do we get it to work. So the core problem that we're running into is that NavMeshLink only allows one unit to pass by at a time, even though it can be set 1,000 meters wide or more, enough for hundreds of units to be passing over it at a time. So what's the first solution that comes to my mind on repairing it? Well, honestly, rewriting the entire thing from scratch is the first thing that came to my mind. But later on, it occurred to me that I can just divide it up and put in where there was 1, now make it 100, now make it 300. So there were 42 different edges on this, and when it comes out to the end, we're going to have about 4,200. All right. So first off, we need to figure out, does it work? And then we need to see what's the code change. And then 3, there's going to be this bug that my code is not susceptible to because of the fact I have a design limitation on mine. But I want to address what that design limitation is, and if you don't adhere to it, what things you're going to have to fix in your code. And I'll still likely have to fix this in a later model, but for now this works. So let's dive in. Does it work? All right, add objects. So it added the objects. That was fast. All right, now, how many links does it have? Let's scroll down, select them all. 4,150. And look at them all. There are 4 dots, editable dots, where I can click and manipulate that it's listening and waiting for me to click on them. There is a curved arrow line. There are the ends of the arrow lines. There is a semi-transparent line being rendered to all of these. This is expensive. My frame rate over here in the editor is horrible right now. Wow, okay, that's just plain bad. So I'm going to select one of these instead, and now I've got a nice smooth frame rate again. Might be a little choppy in the recording, we'll see. All right, so we've got those lines there. Do they work? Let's play and find out. All right, once this comes up, I'm going to press R. And they all start to move. Let's see, do they start navigating? They're cascading down the sides here. We still end up with a little bit down on this side that's starting to cross over, but or starting to follow on that edge. But let's take a closer look. Look at that. We are still having mass numbers of these end up crossing, even though some of these are choosing a diagonal route to do it. I'm not entirely sure why, but it might be to do with competition where it just happens to meet up, and so it hits diagonally and tries to hit another edge to go around. That, I believe, is the case of what's happening there. But you can see that in general it works. It only took a few seconds before all of these units ended up finding where they were supposed to go and navigating their way to it. All right, so this works, great. Now how did we actually do it? First one is, there's one new field on here, NavMeshLink max width. What is the width for the NavMeshLink? Ultimately, in my code, it should be looking at the agent settings and gathering that from over here. Oh, yeah, let me stop the code. Well, whatever. It should be taking the agent type for the nav meshes it's working against and saying, okay, this is humanoid, what's the radius? All right, it's 0.5, so I need to make sure that my distance for each one is going to be twice that, the diameter. It'll be 1. All right, which effectively, that's what I have right now. All right, so let's go into this last one, and it's got all the objects. Let's go into the code for NavMesh Builder 5. Everything is the same until we get to add NavMesh links. Now this, because I had to create numerous game objects instead of just one for every time I called it, I did most of my math up at the beginning, which honestly feels better organized. So in this one, I ended up repeating codes I didn't need to. There's areas I can simplify this, but it basically followed the original code with some modifications to deal with it. So first I've got the edge center, which used to be our starting position. It's not anymore. Next we have our line direction, our width for that line altogether, and then the line normal. So we get that just whatever 1 meter of it would be. All right, then I set up my tri-combo normal, which is the exact same thing. And then I set up my start position, which is basically the exact same thing again. It's that edge center, but we're subtracting the tri-combo normal. So it moves away from the edge back into the model by 0.5 meter. And then I set the starting position, I modify it. So I'm taking the starting position, I'm subtracting line normal, so that direction that we're headed, times the width. So basically that's going to take it from the middle to the middle past it, or basically one full length over, which will be well outside the length. But I'm dividing it by 2, so now we're right at the beginning. Honestly, I could have just used V1 in here minus tri-combo normal instead of edge center, and that would have solved it in one line. And I wouldn't have needed width in here either, because this is the only reason width is technically used. I'm also using it in the loop, as you'll see in just a second. So while width is greater than 0, I am going to continue running this code. And since width isn't used anywhere inside of here, except for this part, I'm just using it to down increment the the counter. It's basically a counter now. Once it gets to less than 0 or 0, then it stops. All right, so every single time I'm going to subtract the NavMeshLink width, max width. That subtracts it. Awesome. All right, so now I have starting position. I'm also incrementing the starting position every single time. At the beginning, it's basically vector 1. The first vector being passed in, that first vertice. All right, our first vertex. And then I'm increasing it by the line normal times whatever the max width is. So as the width is decreasing, the starting position is increasing, and eventually they both reach their endpoints. All right, so next thing, we're creating the game object. I just put in NavMeshLink because there wasn't data that I could add to this that really helped name it and identify it uniquely. This is really more of a click it and see. All right, next I set the parent just as we did before. I set the rotation to match the exact same thing before, line normal and tri-combo normal. And then finally I set starting position. That's different. Before it was this edge center minus the tri-combo normal. All right, so now we create the link, which again, the link is just following the vector 3 right, vector 3 left for start and end positions. And then I'm also setting the width, but the width is the NavMeshLink width. So this is basically, this has no dynamics set up or added to this anymore. And then we just depend on the fact that the starting position changes over here for where the center of that object is, and the width is changing as well, but that width is not being used anymore here. All right, once that reaches the end, it has added all of the nav meshes that we need in here. So now we have these individual nav meshes all the way across it. Tons of them. All right, and so far I haven't detected a notable performance hit on it. It actually seems to run a little smoother, and I think that has to do with the fact that there's just less blockage in the NavMesh AI. So now I did say that there was going to be a bug in the code that we were going to come across. So let's take a look at what that bug is. That bug has to relate to this triangle position. Let me go ahead and show this in the code. There's a to-do, bug on size to resolve. So I'm just going to go into this line, and let's pass it over here, and so you can see it. Now, I'm using a pattern in my code development that shows a specific issue, how we can end up resolving,